Okay, so we're looking at the integration. We're going to be looking at integration initially as the reverse of differentiation. The first two chapters are pretty short, so we're going to incorporate both of them together. So hit pause, copy the lesson objective down. When you're ready, hit play, and we'll talk about integrating. Right, so as it says here, integration is the reverse of differentiation. We can look at it as that. So if we look at the process of differentiation first, what do we do when we differentiate? Well, we take our function first, and then we multiply by the power. Once we multiply the power, we subtract 1 from the power, and that gives us our differential or our gradient. So if we say that integration is the reverse of differentiation, then we have to go the other way around. We start with our gradient function, our differential, and instead of reducing the power by 1, we increase the power by 1. And then instead of multiplying by the power, we do the opposite, because we're reversing it. So we divide by the power, and that takes us back to our original function. Starting as a differential, takes us to the function there. So that's integrating. But there's one other added little complication, a minor complication. So if we had to integrate 2x, well, going backwards, if we had to differentiate first, we've got x squared. Differentiate x squared, we get 2x. Dy over dx is 2x. So if we reverse the process, we get x squared. However, if I was going to differentiate y equals x squared plus 5, I get the same answer, 2x. So reversing the process, I'd get x squared plus 5. So it doesn't really give me an idea of where to get the plus 5 from. And if I have here y equals x squared minus 7, differentiating that will give me 2x as well. So 2x is the solution for all three of those. But there are constants attached to 2 of them, nothing attached there. So each time we integrate, we add that constant. So we call it C, because we don't know what it is. We can't be sure, so we call it C. Right, so for you to make some notes then, there's our reverse process. Increase the power, divide by the power, and that gives us our integral. So this is what we write then. If our differential is x to the power of n, then the integral is add 1 to the power and we divide by that plus the constant term. So we're using dy by dx, we write it like that, and if we're writing it as a function, there's our constant there, and we write it like that. We have f dash of x, then f of x is equal to x to the n plus 1 divided by n plus 1 plus our constant term. So we must always remember to write that C. Hit pause, make some notes. So our general formulas. And when you're ready, hit play again. Right, so here we've got 2 examples. Now in this one, dy by dx is equal to x to the power of 4. So to reverse the process to give us y back, we increase the power by 1 and divide by that. So it's going to give us x to the power of 5 divided by 5. And we've got to add plus c, the constant term, which we don't know what it is. And here, again, dy by dx is equal to x to the power of minus 5. So y is going to be equal to, we increase the power by 1. So we're adding 1. So that takes us to x to the power of minus 4. And then we divide by minus 4. So minus x to the power of minus 4 over 4 plus our constant term. Okay. Hit pause, copy the 2 examples down. When you're ready, hit play and we'll look at another example. Okay, so let's have a look at this example here. What have we got? dy by dx is equal to 6x plus 2x to the power of minus 3 minus 3x to the power of a half. So reversing the process to integrate, y is going to be equal to increase the power by 1 So that's going to be 6x squared and divide by the power 2. Plus, increase the power by 1. So add 1 to that power makes it minus 2. So we've got 2x to the power of minus 2. And divide by that power, divide by minus 2. Minus, increasing the power by 1 takes us to 3 over 2. So it's going to be 3x to the power of 3 over 2. And we divide by that power. And don't forget our constant term, which is equal to, so dividing, we've got 3x squared minus x squared minus, we can multiply by the reciprocal of that divisor there, so it would be minus 3 times 2 over 3 x to the power of 3 over 2 plus our constant term, which we don't know what it is. And so simplifying, sorry, that should be a minus 2 there. 3x squared minus x squared, sorry, x to the power minus 2 minus 2x to the power of 3 over 2 plus c. So hit pause. Let's get that example down. When you're ready, hit play, and we'll have a look at the integral symbol. Right, so using the integration symbol properly, symbol looks like that. So if we wanted to integrate a function here with respect to x, then it gives us our original function plus the constant term, and that's our symbol of integration. Okay, so we're integrating f dash of x with respect to x, and it gives us back the original function plus c. So hit pause. I would make some notes of that. Once you're done, hit play, and we'll look at an example. Right then, so we want to integrate x to the power of a half plus 2x cubed with respect to x. So let's have a go. We want to find the integral. X to the power of a half plus 2x cubed with respect to x. Well, we go term by term. So we add 1 to the power, takes us to 3 over 2, so it'll be x to the power of 3 over 2 and divide by 3 over 2. Plus, increase the power by 1, 4, so it'll be 2x to the power of 4 divided by 4 plus c. So we invert the divisor. Reciprocal of 3 over 2 is 2 over 3. X to the power of 3 over 2 plus x to the power of 4 over 2, or a half, x to the power of 4 plus c. Hit pause, copy the example. When you're done, hit play, and we'll look at another. Right, in this example we're integrating with respect to a different parameter, t. So, oops, integrating 4t squared plus 6, that is a 6. With respect to t, we get increase the power by 1, so that's giving us 4 over 3t cubed plus 6t plus c, and that's job done. Hit pause, copy the example. When you're ready, hit play, and we'll look at one more. In this example, we've got two parameters, because they're not constant. Well, we've got three actually. We've got p, q, and x. So what do? Well, we look at what we've been asked to do, and that's to integrate with respect to x. So we're only integrating the terms with x in, and everything else we treat as a constant. So the integral of 3x squared plus px to the power of minus 2 plus q squared. And you note we put the brackets each time because the dx, or with respect to x, applies to each term in the brackets then. Okay, so it's safer to incorporate the brackets each time. So term by term integration, add 1 to the power, that's going to give us 3x cubed over 3, they're going to cancel in a minute, plus increase the power by 1, so we got p x to the power of minus 1 over 1, over minus 1 rather, plus we treat that as a constant term, so it's going to give us q squared x plus our constant c. Simplifying, we've got x cubed minus x to the power of minus 1 plus q squared x plus c. That's your integral. Hit pause, copy the example down, and we'll look at another. Okay, so let's have a look at this this function here. It looks challenging, but it isn't really if we simplify it. So we've got the integral of 4x squared plus the square root of x plus 5 divided by x squared with respect to x. Forget our brackets. So we need to simplify this term. So it's the integral of 4x squared, which is fine, plus the square root of x divided by x squared plus 5 over x squared. By separating the terms, it makes it easier with respect to x. So if we integrate, we've got 4x squared plus, so this is, we use indices really, is the square root of x, so x to the power of a half divided by x to the power of 2. So we're going to subtract the indices in a second, plus 5x to the power of minus 2 with respect to x. And so simplifying, we've got 4x squared, subtracting the indices, a half minus 2 gives us x to the power of minus 3 over 2 plus 5x to the power of minus 2. I'm going to continue down this side here. Running out of room. Close brackets with respect to x. Oops. It's a minus 2 by the way. Right. So integrating term by term, I get add 1 to the power, so I get 4 over 3 x to the power of 3 plus increasing the power by 1 takes it down to minus a half, so it'll be x to the power of minus a half divided by minus a half plus 5, increase the power by 1, x to the power of minus 1 divided by minus 1 plus c. So that's my equal sign there, equals, so 4 over 3x cubed, and it's going to be minus, and we use the reciprocal, so it'll be 2x to the power of minus a half, and minus again because it's got minus 1 on the, as a denominator, minus 5x to the power of minus 1 plus c, and so we can write it as 4 over 3x cubed. I'm quite happy with that, but because we started using this square root symbol, then we can say that's equal to minus 2 over square root of x minus 5 over x plus c. Okay. So term by term integration. Don't forget your constant. Hit pause, copy that, and I've got some questions for you to have a go at now. Right, so I've got questions for you in exercise 13a initially, and you've got dy by dx equals each one, and then you reverse that. Because it's new still, I think you need to try a few of these. And then I've got some questions in 13b for you as well, where we're using the integration symbol. Okay, so more important. So I shall attach those to the assignment, and good luck.